to do today is be able to get through notes and still give you time to work in ALEKS today, because our first assessment opens this week. So your first sort of quiz that you're taking in ALEKS is already open. Okay, what you'll do is you'll have a practice quiz in ALEKS and then the actual quiz in ALEKS. And it covers anything with our properties of exponents and polynomials. We are done with that unit. We are now starting our data unit. In our data unit, you will not take the assessment in ALEKS because there's too much that doesn't have the same answers. It has varying answers, and so I need to see all of your work. There's not a way to just type in an exact answer going through. So today we are looking at frequency tables. And when we are looking at frequency tables, we are talking about a way that we can represent data. How can we talk about data and info that we get out of it? Okay, so there are different things that this can represent, whether it's talking about eye color, favorite color, whether we look at what your favorite food is, whatever. We have probably all at some point been sitting in a class where either A, we have created our own survey, or B, a group has come in to get information from us. We will not be creating our own surveys this trimester.
Can we do a survey?
Okay? Because we are, again, we're going to be looking at, we're going to sort of do one together as a class, but we won't be doing them on our own individually. So if we're looking up here at this frequency table, okay, this is going to be data that we collected about eye color for boys and girls at Westfield High School.
Black.
Okay, our objective is then going to be to look at this table and to determine some different values. Okay, I just want some of us to think about the fact, like, why you're laughing, you're doing whatever. It's fine. You can think that it's funny. You can think whatever. And just trying to remind you of where you're probably then going to end up being 12 weeks from now. So, how many boys were part of this sample? So if we want to look at this and determine how many boys were part of this sample.
128.
Okay, so that says we want to look at our boys column.
What?
This just isn't going to work.
What happened?
So we either need to make some better decisions or we'll find another place to be.
What do you mean? What do you mean?
You won't be sitting in the classroom for the rest of the period.
Oh, like half the period?
Nathan?
Isn't there a desk outside? Yeah, there's a desk outside.
So if we look at how many boys were part of the sample, we want to go to our boys column and we will add up the total of how many boys were in the sample. Okay, so if we go down our list here and we add up, just in your calculator, 44 plus 21 plus 63, what do we get as our total?
128.
128. Okay, so we would say there were 128 boys in the sample. This question is just asking how many. And my students are always fine with this when we ask it first, but when we go in reverse order after we've done percents, it's important that you note that difference. Number 2 then says how many were sampled in total. So if we want to know how many were sampled in total, right, we're going to add up all of the columns. Did you already do that, Bailey? And what did you get? 252? I don't have the number off the top of my head, so are we agreeing? Anybody else add them all up and we got the same thing?
Yes.
Perfect.
100 for the girls.
Okay, so once we are able to calculate those total values, well, sometimes it's useful. It's not really our end goal. Okay, the reason why it's useful is because what if I said, class, I took a survey about students' favorite teachers, and 100% of the surveyors said that Mrs. McKinney was their favorite teacher. What would probably be some things that you would want to know?
Why?
How many people did I ask? What happens if I only asked one person? Ooh, that doesn't work very well. What happens if I told that student I'd give them an A if they answered me? That probably isn't going to work very well, right? So there's some other pieces here that would probably be important to know. Okay, so it's important information that if a cell phone company tells you we're the best because of XYZ, you know how many people that actually was pertaining to. We then can calculate what percent of students in the class are boys with brown eyes. So whenever something is asking us to calculate what percent of something, percents are always a fraction, which means every single point that you are calculating a percent, you will be writing down a fraction. Okay, where the number on the top of the fraction is always what follows the word of. Okay, whatever goes on the bottom of the fraction is sort of our verb, or prepositional phrase, depending on the wording of it. Okay, so depending on what we're surveying, depends on what sort of action thing we might see here. So what students picked this, preferred this, are this, have this. Okay, whatever follows that word is going to go on the bottom of the fraction. Oh, I just did that backwards. I do this every time. These go flip-flop, guys. Oh goes on bottom. I swear, it's just because of comes first that I always say. Okay, so R. Preferred. Where our verb is there, sorry. Are, picked, prefer, have, sort of your verb or prepositional phrase.
Yeah.
So if we say what percent of students in the class, so we want to identify students in the class. How many students do we have in the class? Not this class, but in this setting. 252, because we already calculated the total. So 252 is what's going on the bottom. Are boys with brown eyes. Okay, so if we want boys, we need to be in the boys column with brown eyes. So 63 goes on top.
0.25.
Okay, so Sarah then divided them, and when you divided it, what did you get?
0.25.
0.25. Now, this tells us the decimal form. It does not tell us the percent form.
25%.
Okay, so you either know that you're going to move the decimal point 2 to the right, or you can just multiply by 100 in your calculator. Okay, I am telling you right now that you always need to read the instructions, but if there are decimal points left after that, you need to give me 2 decimal points past the percent. Okay, so 25.67, if there were more decimals there. Now, read instructions because it will tell you where to round to on state tests. In ALEKS, it's always going to sort of tell you something different depending. So make sure you read carefully. Okay, number 4 says what percent of the girls? Okay, so what percent of the girls? So what comes after of is what goes on the denominator. So we need to know how many girls there were. So if we add up our totals for girls, how many girls do we get?
124.
124, are we agreeing with that? Have blue eyes. So now we want girls that have blue eyes.
39.
Which is 39. Okay, so if we divide that to figure out the decimal, right, in our calculators, we're just dividing out the fraction that we see. So 39 divided by 124
What's the day?
gives us 0.314516, blah, 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 blah. But we want this as a percent.
131.
30.
So we want the decimal 2 to the right or multiply by 100. So if we move over here, then we're going to 31.4 what?
Percent.
4.
5.
How do we decide if we want to round that 5 up or not?
If
It's
it's
over.
I could.
Right? I'm looking at what's after it. If it's 1, 2, 3, or 4, it stays the same. If it's 5, 6, 7, 8, or 9, then I'm bumping it up. So 31.45%. Number 5. What percent of the sample have brown eyes? So we need what percent of the sample?
So 63.72.
The sample means what?
All of it.
All of them. So what is the entire sample total?
252.
252
135.
have brown eyes. Okay, so Dylan, right, you were saying to add these two things together,
135.
and that gives us a 135. So then we'll divide. .5357114. What would we leave this as our percent?
53.57.
53.57%. We're doing okay so far. Number 6. I'm gonna have to look at balls, so we'll pull this up here. How many boys have blue or green eyes? What are we gonna do to start with?
Add the blue and green eyes to the
Okay, so we add blue or green eyes together of who?
boys.
The boys, and what do we get? 65?
Sure.
Then what?
You put it over 128.
Do we?
No.
Do we want to do this?
No.
Why not?
Because it doesn't ask what
It doesn't ask for a percent.
65 boys.
So make sure, right? This is just 65 boys.
Yeah.
It's a really easy mistake to make, especially like when you're working in Alex and you do percent after percent after percent after percent, and then all of a sudden it just says how many.
Set.
Number 7. How many girls do not have blue eyes? What's another way that we could word that question?
How many girls don't have blue eyes?
How many girls have green and brown eyes?
Right? How many girls have brown or green eyes? So we want to calculate everything that's not blue.
85 girls.
Okay, so we're going to add up all of the girls that are green and all of the girls that have brown eyes. And we get a total of 85. Are we okay with that? Okay, so just like with that not word, we can do the same thing with the percent. What percent of boys and girls? So what percent of boys and girls is saying what percent of the sample? So how many was our sample? 252. Do not have green eyes. So we're finding the number that do not have green eyes. So we want all of the brown and all of the blue. And what do we get? 218. Okay, so then we're going to divide.
51%.
here's our decimal. So if I move my decimal point 2 places, what am I gonna put for my rounded percent? 86.51, right? Because my 7 here is larger than 5, right? 5 or above, so I'm bumping that up. Okay, so I want you to flip this paper over, and on your own, I want you to answer all the questions on the back. Those numbers just are not right. Right, but then, yeah, as your decimal, and then when you multiply it times 100, right, you'd have 8. Does that make sense? Does that answer like one of them? So we have lots of different numbers going on.
Can I use the bathroom?